system in which a message is placed in a circular queue by a message sender and removed from the circular queue by a message receiver, which can also display the contents of the queue. And to implement this, we are going to be making use of the circular queue data structure. So before we go into the specifics of the program, I think it's important to understand what exactly circular queues are, why they're important, and what their applications are. So what is a circular queue exactly? A circular queue is basically a linear data structure in which operations are performed based on the first in, first out principle, just like any other queue. But only here, the last position is connected back to the first position, making it a circle. So in a normal queue, we can insert elements until the queue becomes full. But in a circular queue basically stores the data in a circular fashion, and this means that, say, the last index of your queue is filled, instead of saying that the queue is full, what the program will do is to circle back and check for empty space in the queue, where the element that we want to push can be inserted. For the ease of the enqueue and dequeue operations, two variables, that is front and rear, indicate the front and the rear of the circular queue, where elements can only be added at the rear and removed at the front. The appropriate terminology being enqueued and dequeued. So in order to explain the exact working of the enqueue and dequeue functions and of the general messaging system, let's get into the program. So the first thing that we observe here is that we've defined two constants, that is size and m size. So size basically represents the length of the circular queue, whereas m size represents the length of the message that can be sent using this messaging system. We are representing our queue as a structure which encloses two variables, front and rear, which indicate the front and the rear of the circular queue respectively, and a character array, a two-dimensional character array, CQ, which is of dimensions size by m size. So it's almost like we have an array of strings where the length of the strings can be m size and the number of strings is denoted by size. So when we declare a structure variable, the very first thing that we will do is initialize all of the variables. That is, we will initialize front and rear to -1. Now we can proceed into our enqueue, dequeue, and other operations. So here, enqueue operation is basically the same as sending a message. So before we send a message, the first thing that we'll have to check is if our messaging queue is full. That is, check for overflow condition. So in the case of a circular queue, the condition for overflow is either that Q rear is equal to size -1 and Q front is equal to 0, which is basically the overflow condition for any queue. And the additional condition here is Q rear plus 1 is equal to Q front, which is specific to the circular queue. So satisfying any of these conditions will indicate that the queue is full, and hence we cannot enqueue or we cannot send the message. Now say this is not true, we can proceed into the rest of the function. So the first thing that we're going to do is we're going to check if our queue rear is at the very end of the circular queue index, which would mean that adding a new element would shift the index from size -1 to 0. And hence, to allow this to happen, we're going to set Q rear is equal to -1 if Q rear was equal to size -1. After checking for this specific condition, we can go ahead and increment the rear variable and then, using strcpy, copy the message that we want to enqueue into the element at the rear index. Before exiting the function, we check if our Q front was -1, which was the case where there were no elements in the circular queue. And now that we've added an element to the circular queue, we can increment Q front, and hence Q front will be equal to 0. So that was about the enqueue operation. Now speaking of the dequeue operation, basically what we'll be doing here is removing the message at the front of the queue. So obviously before we do this, we will have to check if there are any messages available to remove. That is, check for underflow. And so the condition that we will be checking for here is if Q front and Q rear are equal to -1, which, as I mentioned earlier, represents a state where there are no elements in the circular queue. So if this condition doesn't hold true, then we can proceed to the rest of the function. So now what we're trying to do is we're printing the message at the front of the queue. That is the message that we want to dequeue. And we're receiving this message. And hence we're saying message received %s/n. The next thing we're doing is checking if Q front was equal to size, which means that on removing a message, Q front will become 0. And then we're going to check if Q front -1 is equal to Q rear, which basically means that there is only one element in the circular queue, and hence removing that one element will mean there are no elements left. And as mentioned before, the condition that represents an empty circular queue is when Q front is equal to Q rear is equal to -1, which is what we will assign if, say, the previous condition is satisfied. So that's all for the dequeue operation, or in the specific case, message receiving. The third functionality that we required was to display the contents of the circular queue. So obviously, the first thing that we're going to do before trying to display the contents is to check if there are any contents, which means that we're checking if Q front is equal to Q rear is equal to -1, and say this condition is satisfied, then the queue is empty, and hence we're going to print that and exit the function. Now we have two cases, and hence two different ways to display the message queue. So the first condition here is if our front is smaller than or equal to rear. So in this case, we can start printing elements from the index represented by front and up to the index represented by rear, which will basically mean that we're printing all of the elements of the messaging queue as they all lie between front and rear. Now in the other case, which is when front is greater than rear. Now in this case, we'll have to display in two parts. So firstly, we start printing from front to the very end of the array, or basically till index size -1. After this, we circle back to the start of the queue and start printing from I is equal to 0 up to rear, in order to completely print all of the contents of the messaging queue. So that was about the display function. And one thing that I forgot to mention here are the parameters that each of these functions take in. So the initialization function just takes in a pointer to the structure variable of the queue. The enqueue function takes in the pointer to the structure variable and the message that we want to enqueue. The dequeue operation just takes in the pointer to the queue and does not return anything. It just prints whatever message we want to receive. And finally, we have the display function, which takes in again a pointer to the structure variable and nothing else. So we can finally go into the main and just quickly summarize what we're doing in the main. So as we can observe in the main, this is a menu-driven program where we're giving the user the option to send a message, receive a message, display the message queue, or exit. So let's look at case 1 when we're trying to send a message. So first we input the message from the user, and then using the enqueue operations, we pass that message and a pointer to whatever structure variable we've declared. And then using the display function, we basically display the updated contents of the messaging queue. In case 2, where we want to receive a message, we basically just use dequeue, and dequeue will print message received in case there are messages that can be received. In the third case, we're just displaying the message queue using the display function. And finally, when the user inputs 4, we're printing exiting and then just breaking out of the loop. And the condition in the while loop is that C is not equal to 4, and hence giving an option C is equal to 4 will automatically end the while loop. So this was about the messaging queue program.